Whenever you are calculating moment, you always have to take the force into the distance. And if the question says the system is in equilibrium, you have to apply F1 D1 is equal to F2 D2. And then you can do simple calculation like this one. We are doing presently example number 2. Remember that distance is always taken from the pivot. Distance is always taken from the pivot. So F into 30 is equal to 20 into 30 plus 30. So please solve it and compare the answer. F into 30, this is the right point. F into 30 is equal to 20 into 30 plus 30. And the answer is 40 Newton. Example 3, there is a ladder. There is a ladder. There is a ladder. We have a normal reaction. The ladder is in equilibrium. So first copy this question. So when you have to find the moment, you always have to take the distance from the pivot. We have the pivot, we have the forces, and remember that the forces are not directly given. He has given us the masses 40 kg, 50 kg. So the question has given us masses. Mass itself is not a force, it has to be converted. But whatever you take, suppose you take this distance. So when you take this force, you have to take this distance. When you have to take this force, you have to take this distance. When you take this, you have to connect it with this. So always you have to take the perpendicular distance. Yes, we have to multiply the masses. Now, this time we have to multiply by 9.8 after the syllabus update. This is an older calculation that I have used 10. The value of G is 9.81 Newton per kg onwards. Now give the heading center of gravity. Center of gravity, let's put the definition first. The point at which the weight of a body is assumed to act. This is the definition. So its short form is CG. So please copy down the definition. CG is a point where an object can be balanced. So this is a very important concept. If you want to balance something, you can put it on the CG. So when you put something on the CG, the object will be balanced. This is the first title, center of gravity. The first concept is there that CG is a point where an object can be balanced. So if you pivot it at the CG, it will be balanced. So you have to copy this first concept. Now, our second concept in this article is the idea that CG, center of gravity, is not a real is not a real point. Center of gravity is actually like an imagination. Gravity is actually acting at every point. Gravity is actually acting at every point in a system, in an object. Gravity does not focus on one point, but what we do, as all the forces are as all the forces are acting like this, so we assume a common arrow. We concentrate for an assumption of a common arrow, and this common arrow position is called CG. So CG is an assumption. CG is an assumption. This is a point at which the weight of an object is assumed to act. So now you have to copy this. Now, our next concept, CG for a regularly shaped object is the geometrical center of the object. CG for a regularly shaped object is the geometrical center of the object. So this is the idea of a regular shape object. Regular shape object means like the triangle, you can see a circle, a sphere, ellipse. So here the CG is at the geometrical center. For these objects which are symmetrical, the CG is at the geometrical center. So this is our next concept. You have to copy this. Now, we move to our next concept. When we are dealing with an irregular shape object, we use a method. If we are dealing with an irregular shape object, like any random shape, then we apply a method which is called lamina method, So you have to copy this. Now this is called a lamina. Look, this is a lamina, plumb line lamina. So lamina is a card, is a random shaped card, and we are hanging it from a position. This is called a lamina. We hang the lamina from the plumb line, and the plumb line is a string with a metal bob behind the lamina, just like when you hang a picture, or when you hang a calendar on the wall, you make a hole in it. So we have made multiple holes on the sides of the lamina, and we are hanging it from a position. Now we will this is the appearance. Now we push the card. We push the card and allow it to oscillate. When when we push it and allow it to oscillate, it will come to rest when the CG is right below the pivot. Look at this position. It will swing and it will come to rest when it is right below the pivot. At this point, we will stop the, we will draw the lines on the card. We first push the card, allow it to move, oscillate freely, and when it comes to rest, we record the position and we draw lines on the card looking at the pivot position. If the CG is not below the pivot, if the CG is not below the pivot, the object will continue to move. It will keep on swinging. So once the once the card stops, we draw a line on the card looking at the lamina and the plumb line. And then at this point, we when the card is oscillating, so when the card stop at a point, we draw lines on the card, and then we hang the card from another position. We hang the card from another position and keep on drawing line on the card until we get multiple lines. And like this, we get multiple lines like this. And when you get multiple lines on the card, the common center is called the center of gravity. The common center is called center of gravity. This is the center of gravity. Look, this is the center of gravity. Okay, now you have to copy this diagram. Let me know once you have copied it. So we initiate by an impulse. We initiate by an impulse, and we push the card gently and allow it to oscillate and allow it to oscillate. It will swing and comes to a position. Now you have to copy this screen, the procedure. I'm just coming in a minute. Copy this screen. The effect of the position of the CG on the stability of simple objects. Not to copy this. The effect of the position of center of gravity on the stability of simple objects. So let's put the first point. Position of CG determines the nature of equilibrium. Like this is a toppling position and you can shift it on two sides. So this is the first concept to remember. CG position determines the nature of equilibrium, like a ship, like a bicycle, like a motorcycle. When you're driving it, you can balance it on the center of gravity. Now you have to copy this. Lower the CG, greater is the stability. Now copy this. Lower the CG, greater is the stability. Like this is a object with a heavy block base. This is a high-rise building, and look, the conventional buildings when they used to make in the previous design, older design, they used to make high-rise buildings. In the high-rise buildings, they used to make the CG low, and lower CG used to provide greater stability. Racing cars, they have a low chassis, low suspension, so that they become stable. Not even racing car now. Other cars or also have a low CG. So common stability issues, when do they tip over? How does adding mass to an object change its stability? For example, liquid in a wine glass or adding modeling clay to a ruler. This is an example of checking the stability. Now give the heading center of mass. This is a new heading. The point at which the mass of a body is assumed to be concentrated. Now copy this. Normally, in our past paper, center of gravity and center of mass coincide. Technically, they are different, but in O level, we do not consider them different. They are considered to be common points. You have to copy this. Center of mass or center of gravity are generally mobile points. They move according to the mass distribution. It means that CG or CM can move. Now look at the CG. It is in the middle of the glass. We put water in it halfway and the CG goes down. Then we put water again. The CG goes up. So CG moves. CG is a mobile point. So right under it, the CG or CM are mobile points. You have to copy this. Now copy this. Copy this showing that CG is a movable point, and let me know once you have copied it. Okay. So we stop here and we will inshallah continue in our next class. Allah Hafiz.